Welcome back, everyone. I've heard a lot of good conversation during this lunch, and I'm so glad that all of you, all the most core React fans, are here today and are able to meet some other people and talk about some crazy stuff. So, talking about crazy stuff, James Long here is going to talk about CSPs, and you've probably never heard of them before, and really you're missing something out. So here is James.
Thank you. Okay, let's see. So I'm James Long. I work on the developer tools for Firefox, mostly on the debugger. So sorry about bugs and that. We're fixing them. I also I write at jlaunch.com multiple articles about React and JavaScript and general programming language research. You may have seen my recent post presenting the most over-engineered blog where I just played around with server-side rendering. And this is my daughter, Evelina. I stole this technique from some other presenters from Mozilla that like to show kids in the beginning of their presentations. Just to warm it up. So I'm excited to be here today. Unfortunately, I'm going to talk about asynchronous JavaScript, which is something that everyone talks about. It has a lot of opinions about, but it's because it's really fundamental to what we do. It's really important because almost everything we do on the web, pretty much anything in a connected environment needs to work over asynchronous operations. It affects everything. But if you're tired about hearing promises and streams and events and all that kind of stuff, you'll be glad to know that I'm not really going to talk much about those today. I'm going to talk about channels. I'm going to talk about a specific type of channel that comes from the concept of communicating sequential processes. This is a term coined by Tony Hoare a few decades ago. And there's been a lot of research on channels since then up until now. So I'm going to show you why I think channels are cool. So CSP is not content security policy. It's communicating sequential processes. I'll try to just say channels from now on. So this is an exploration into what happens if we introduce channels into React. What will it look like? Does it fundamentally change how we interact with our components? Does our components interact with each other differently? What does Flux look like? Does everything explode and it's just terrible, or is it actually pretty nice? So this is just an exploration. This isn't something that I've been using in a large app or anything like that. This is just a look at a different technique. I personally think that it simplifies a lot of asynchronous operations and complex workflows, and you'll see why in a little bit. So there's not really any new concepts here. Go and Clojure script have been utilizing this for years, and it's been great. I really only helped port them to JavaScript and studied how to apply them to React. So first I'm going to explain channels in a little bit more detail. And then I'm going to show some examples of integrating them with React components. And then lastly, I'm going to take a look at Flux and see how they might be re-envisioned with channels. See which parts of the Flux architecture can be done with channels and which parts might not be. So let's make ravioli. For making ravioli, there's a couple steps. You make the meat, you make the noodles, and then you make the sauce, and you grate the Parmesan. I don't want to do all this myself, so I get some helpers to help with it. If this was a promise analogy, you would tell each helper to do one thing. When you need that thing, you go and get it. If they're not done, then you wait for it, of course. And in the end, you combine it all into ravioli. I'm assuming you're using generators with promises. If you're not, the analogy would be something to wherever you interact with a helper, you need to go and take all of your current ingredients and go into a new kitchen. It's really awkward. But if you're using generators, it's really not. If you're using generators, it doesn't seem like that bad of a workflow. But the producers are pretty limited, right? They can only produce one value, and that's inherent in promises, of course. They're outright saying that they're not streams. Personally, I think that's a false dichotomy. There's a very tight coupling between the data and the code flow. If you want to do something with the promise, you need to create a new promise, right? Every single execution in the code flow is dealing with promises as well. So I'll explain a little bit more about that later. If this was an event analogy, you'd pretty much just be throwing plates across the room and you having to be awkwardly catching them, and it's just terrible. If this was the reactive extensions, which is based on the FRP concepts, it improves a lot. It actually is the closest to channels out of all of this. But there's still a tight coupling between the data and the code flow. To work with streams, you need to execute a stream and merge streams, which creates a new stream. You're still talking to the helpers. So it's kind of like speaking Italian. So it's a little bit better if you're making Italian food, but it doesn't really help if you're making French cuisine. And streams, the Streams API helps a little bit too, but I think it suffers from similar problems as the other ones do. I haven't looked as closely at streams. So channels, you would imagine helpers being every single helper is in their own kitchen, and the channels and the kitchens are connected with conveyor belts, and the food is passed on the conveyor belts. So I don't care what my helpers are doing, as long as I get the food at the right time on the conveyor belts, then it just works. So the helpers are individual entities, actual human beings that are doing things independent of me, and we talk on these conveyor belts. So that's kind of the analogy. There's 4 fundamental operations when you want to deal with channels, and I think the resolution messed this up. Chan creates a channel, Go starts a process, take takes a value, and puts a value. So these are the 4 fundamental operations that you are doing when you're working with channels. So this is some code. This is using the js-csp project, which is a project that I've been contributing to. This implements channels in JavaScript. These are essentially goroutines in Go, and in Clojure script they have core async, which is this is js-csp is essentially a straight port of core async into JavaScript. I did not start this project. Uwe Lonton, I'm not sure how to say his GitHub name. I think he's in Vietnam. I'm not even sure how to say his full name. He's the one who actually did the initial port, and I've been helping contribute to it. So this example, we create a channel, and then we spawn 2 processes. And within these processes, we yield. We yield operations on the channel. So you can see that we say yield take, and it takes a value. And it looks like it's infinitely looping and infinitely logging these values. But it's using generators. And generators allow you to pause execution of a function at any point in time. This is critical to CSP work, where you can pause execution, because you get to use the exact same constructs to express your asynchronous complex data flows as you're using in JavaScript. You get to use if, you get to use while, you get to use anything that you're used to. So if you think about reactive extensions, you don't do these, right? There's a whole other language that they've invented to talk about streams. It's not the case in CSP. We have distinct entities between, or distinct differences of processes and channels. Processes execute independently, and then when they want to operate on a channel, whatever they're doing blocks. So a take block. So this while loop is waiting for a value to come through. The second process puts 3 values onto the channel. These put operations block as well. So a taker and a putter has to be available on both sides for the processes to continue. So in that way, it's can be used as a rendezvous mechanism. When a transfer successfully succeeds across a channel, you know that those 2 processes are at the exact same point in time within their code. We actually do the take operation by default. So since you're already using generators, you have to say yield. So saying yield take every single time is a little bit much. Go and Clojure script don't have this. They have a special syntactic form for a take that looks more like a take. But since we don't have we do have macros in JavaScript, but since they're not used very much, we go ahead and just do a take by default. So you can just yield a channel. You still have to say yield put to put a value onto the channel, but that reads pretty well anyway. So this program just basically will print 1, 2, and 3. So if you can switch over to the live coding. So if I copy and paste that code, you'll see in the console that it's outputting 1, 2, and 3. Let's see if I can make this bigger. So just 1, 2, and 3, right? So I've written an add-on to the Firefox DevTools which visualizes the asynchronous execution of your flow. Essentially, you can press record, and when it starts recording, it will show you the processes of the program and show you the values that are transferring across those processes. So if I press record here and press run, you can see that 2 processes were created and some values are transferred. Now, you can't really see those values. Let's just, for demonstration's sake, add a little timeout. The timeout just returns a channel that closes after a specific point in time. So it basically just blocks the process for this short amount of time. So if we record and run it, you can see that this second process, foo, is giving values to logger. And this first one happened after 100 milliseconds. which I wrote, and then it waited 500 more milliseconds, and then it passed another value. You can hover over these arrows to see the value transferred in the top right of the screen. It says value 1, 2, and 3. And I could execute tons of processes going off in my program and kind of see the nice asynchronous workflow. This is the difference between promises and streams and all of that, where it's coupled with the data and the code flow. If you ever look at a promise debugger, all it shows you is a list of the top-level promises and then this massive promise chain. Because to use promises, you literally have to keep morphing up promises. For us, we have this separate idea of a process and then a separate idea of a channel. So we get this really nice visualization where you're just dealing with this one asynchronous, this one expression of an asynchronous flow. That's all you see in it, and you can see where the values are coming in. And of course, we could visualize this a little bit better. We could nest it, so that's nest it by file and then function, or file and then class and then function. So there is a little bit of hierarchy there. But it maps a lot better to how your code is actually structured statically, not how your code ran. OK, so let's. I'll show you a few more examples of live coding just to show you a few more properties. So this starts two processes. The first one is does the while true loop again. You'll actually see that a lot with CSP because you're essentially creating these little mini event loops. So it gets a value from the channel, and it waits for 500 milliseconds, and then it puts a value back on the channel, and it multiplies the value by 2. So the second process puts 1 on the channel, and it gets the value back off the channel, and it logs it, and then it waits a little bit. And it does that 3 times. So it puts 3 values on, gets the value off, and it waits for a little bit. So you can see in the console, if I clear it, 2, 4, 6, because it was waiting a little bit in between. And if I visualize this, you can see this nice dance. This is actually the classic ping pong example that they show in Go. So you can see that the arrows show that foo passed the value to logger, the value of 1. Logger passed 2 back. And then foo passed 2 to logger, and then it got 4 back. So you can see exactly this ping pong interaction. All right, one more live coding example. This one just shows you can have multiple processes. This is the same thing as the first example where you have one process just logging stuff. And then here we have 2 processes instead. So here you can see that we just have two processes that are just shoving values into the logging process. And of course, you see these values being logged. So multiple values can be putting values onto a channel, and one process can be taking values off of the channel. So I think it's pretty cool to be able to see this whole flow in your program. So if we can express our programs like this, this is potentially one of those abstractions that is very useful because we get a lot of stuff for free. We can visualize our programs like this without actually having to, say, implement specifically a Flux visualizer. We could implement a CSP visualizer and get just a lot of stuff for free. This is what I love about React. It's just such a great abstraction because you can use it in so many places, just like they're doing with the iOS and native apps now. Good abstractions are like that. You suddenly get all of this really good stuff for free. So this is potentially like that. I'm not saying it actually is. This is what we're just looking into. And I actually meant to say before that a lot of this is based on David Nolan's work, which he is going to be here tomorrow and giving a talk on. So I'm giving him credit for that because he really did pioneer a lot of these ideas. Go initially implemented CSP, and then the Clojure community has really taken it a step farther. So this is just a quick example of a promise-style interaction. So the Go, which starts a process, returns a channel that has the value returned from the process on that channel. So it's just like a promise, right? When you say Go, does some stuff, and it returns a value. This one actually doesn't return a value. I could say return 5, and logged would be a channel that has the value 5 on it. But basically, in the second process, we're just waiting for logged to finish, and then we say done. So the first process waits for a second, and then it says hello, and then it exits. And of course, you can see it in here as well. So this is entirely exactly the same as working with a promise. You spawn a promise, and then if you're using generators, of course, which you pretty much always want to be using generators, because you're always going to want to go back and do more asynchronous work within that generator. So this is exactly the same. People complain about like if you force streams, force a stream style API into doing promise style work, that it's just you're adding a bunch of complexity for not really much gain. But this is promises the entirely exact same API. And additionally, we don't gobble your errors. So we actually properly do error handling. Because, yeah, so you'll actually see X is not undefined in your console. It's really good. There's a whole other error handling story, which I don't have time to go into. OK, let's see. So can you go back to the slides? OK, so there's a few more features that I don't really have time to go into. There's promise channels, which are coming soon. This is something that Clojure has recently implemented, so we're just going to copy them again. Promise channel is basically the same thing, except you can only put one value on, and you can take as many times as you want, and you'll get that value back. Normally, when you take the second time, there's not a value available, right? So it would block. But promise channels will return the same value for as many takes as you do. You can close a channel, which is basically like a signal. So when you close a channel, if you try to take from that channel, you'll get back a special object, CSP.closed, which you can compare to CSP.closed to see if the channel closed, if you're blocked on it to take. And if you try to put on a closed channel, then you'll just get back false. So that way you can conditionally do operations if a channel has closed or not. There's other advanced operations that are compose the channels and compose into complex asynchronous workflows. So Molt will take a channel and return an object that you can add other channels to. And when you put a value on that first channel, all of the channels that have been added to it will get copies of that value. So it's like multiplying values. Mix is kind of similar to merge, where you can actually mute the stream and do all these complex async operations. Merge just takes a bunch of channels and returns one channel and merges all the values into that one channel. Pipeline is a really complex asynchronous workflow. So now that we have this concrete data structure of a channel, we can really easily compose it into these really nice ways. So I'm gonna skip that last demo. So there's also custom buffering. So now that if you think back to the conveyor belts, you can have multiple different kinds of conveyor belts. So the default conveyor belt, you can only put one piece of food on it, and the putter or the taker will wait for the other putter or taker to take or put it. But there's multiple things, like you could have a conveyor belt that has room for 5 pieces of food. So you can put 5 pieces of food, but once it has 5, if you go to try to put something else on it, then you've got to wait for somebody to take one of those pieces off. So that's buffering. There's dropping and sliding buffers, which say if there's 10 pieces of food on the conveyor belt, and I go and try to put something on it, it's full, so I'm just going to throw it away. So this way we can do complex throttling semantics, and it's really nice. There's also transducers. There's so many things to talk about. I don't have time to go into this. So how many of you know what a transducer is? Oh, awesome. OK. Well, I'll kind of skip this, but you can pass a transducer to a channel. Any value going through that channel will be run through the transducer, which is essentially just a transformation stream. And it's not specific to CSP. This is actually using a transducers.js library. This is why transducers are so cool. So why isn't this used so much? I think it's because mainly it's because generators haven't really been available until recently. It's just an idea that hasn't been used. One problem is that it's susceptible to deadlocks, but I think that's what the visualization tools will help. So let's deal with component event handling. Let's just make fun of CSS or something. It's Keynote. But so this is a simple list. Can you go over to my computer? Oh, wrong one. So this is just a simple list that I say hello. I can add stuff to. What I basically ended up doing was the code here is pretty simple. Let's see. So this is the classic React code, right? You have an input, you have an on change, and an on key down, and then you have it like a handle create when you actually submit the button, and then you have these event handlers up here. Well, what I did was I introduced a new concept where I was saying, hey, what if instead of these event handlers, we actually sent them to channels? And so could you switch back to the slides, actually? So it's a really simple thing. You have these 3 components, which, rendering flows down, data flows up, classic React. I introduced a channels mixin, which is unfortunate because we're getting rid of mixins, evidently. But we're channels mixin adds a send method to the component, which it basically creates an event handler that you can pass to React's event handlers. The send method takes a name and arguments. If a method exists on the component with that same name, it simply treats it as a normal event handler. Otherwise, it sends the events onto a named channel. And I'll show you what that is in a second. There's another method, getEventChannel, which will get an event channel. And it takes a name and gets it back. OK, can you switch back to the live coding? So I rebuilt that demo. And so basically, this is what it looks like now. So you say this.send handle typed, and then this.send handle create. What this does is it checks if the method exists on the component. And these methods all actually do exist. So you can see handle typed and handle create. So here I found there's really no advantage to channels. A simple event firing mechanism is fine here, right? So you don't need to use channels everywhere. There is one really nice thing is that I ended up being able to use the transducer style API here. So now I can pass the transducer to my send method. It's not using channels, but it still runs the value through the transducer because transducers are awesome. So it's really easy because I don't have to have the on key down handler, the on key down event handler anymore. I can just go ahead and immediately send it to handle create if the key code is enter. So that was one nice thing. Can you go back to the slides? I told you I was going to be doing that a lot. That was cool. Let's look at another example where there might be some more benefits. Recording the mouse. So this is more of a stream, right? So if I click record position, it's recording the position of the mouse. If I click record velocity, it takes the last mouse coordinates and the current ones and subtracts them. So if I go fast, it's bigger. If I go slower, it's smaller. You can see if I press record, you can see the process going on right now. And this actually, if I switch to record velocity, you can see a second process started. So you can see, you get this idea of what's going on in the system. We can hover over these and see the actual values that were sent to the system. And these aren't errors because they came from the native world. So there is no from, right? So the interesting thing about this, if you can, is that I'm going to compare the normal React style to the channel style. So I'm just going to skip over some of it because I'm running out of time. But in the channel style, we basically say on the mouse move, send it to the mouse chord channel and map the event to the coordinates. So just send the coordinates to the mouse chord channel. Mouse chord right here is not a function on our component, so it creates a channel. And up in our velocity record method, which this is just called when you click velocity record, this fires off a process, and it gets the event channel using getEventChannel of mouse chord. So now we have a channel. So we have this endpoint where the coordinates from the mouse are being streamed into. We do a while true loop, right? We create a local event handler. And then here, this is where we do our operations. We say if we're not stopping, if we don't have a prechord, set the prechord. If we do have a prechord, then calculate the velocity between our current coordinates and the previous coordinates and output it to the state. And this is a while loop. So this is just continually happening while we're getting input from the mouse. So if we look at the normal React style, it looks simpler, right? It is actually shorter. It's quite a bit shorter. But you'll see that this incidental state right here, it's sticking prechord onto the component because it has to put it somewhere, right? Because event handlers, there's no state, there's no tracking between one firing of an event and the second firing. So, but it needs the prechord, so it's got to put it somewhere. In the channel style code, we just have it as a local variable. So we're able to use our local variable as just local state, right? And that's kind of this whole idea. Is when you put things into a process, you can express the complete workflow in one place. We could pull out this Go function and put it into a completely different file, different library, and just spawn it off. And if we were interested in waiting until it finished, then we would get the channel back from the Go process. And we could block on that if we wanted to. But this over here, you can't, the other one that's the React style, this is embedded into the component. It's not modular at all. So we're starting to see that we can abstract out behaviors. and asynchronous workflows. Okay. So this is another another demo. This is the last one for the React stuff. So this is a tooltip style interaction, right? So if I hover over this and I leave real quickly, it doesn't do anything. But if I stay hovered over it, something pops up. And if I leave, then it goes away. So that's like the tooltip functionality, right? So if you hover really fast, this is a classic kind of interaction that where you start to get more complex with the users. Users are hardly ever just a one fire and forget event handler. They're always like, when this event comes in and this other one comes in a little bit later and something else does not happen, then do this thing. And it's super hard to express with event handling and even streams, because you got to track the state. So you can see in my debugger as well that as I hover, every time I hover, it's starting a new process. Another thing I didn't show you before too is if I click on this process, it'll jump over to the code. So you can see exactly that code that's going on in that process. So it's treating this tooltip as a process. And that's the whole idea that David Nolan started blogging about a while ago, and I think is a really great idea, is that you're extracting processes from your workflow and putting them into an explicit process. So you can actually literally see, if I go over to the code, you can actually literally see that the tooltip start is literally just this code. This is the complete implementation of that. And what we do is down here in the element that we hover, we can say on tooltip start, or on mouse over, send it to the tooltip start. On mouse out, send it to the tooltip cancel. So we implemented the tooltip start as a method. So that's just a simple fire and forget event handler, right? However, this starts a process. And the tooltip cancel is a channel that we get. And that channel ends up being what we call like a cancel channel. So basically, this is another operation with channels that you can do, which is alts. It's basically like a networking select. It says, give me back the first value that comes from either of these processes. So this is saying on yield this alts operation, either the user has, or either a signal has come through the cancel channel, or a timeout of 500 milliseconds has happened. And you get back the channel and the value. So we say if the channel is not the cancel channel, then we want to show the tooltip because the user has hovered over the element for 500 milliseconds. So we set the state of tooltip to true. And then we yield cancel because we still have that cancel channel, which represents the user moving off of the button, right? So we can still use that cancel channel and say, well, let's just wait until the user has left. And so when the user leaves, then we change the state to false to hide it. So this is a perfect example of where extracting processes from your event handling code just makes it so much clearer into exactly what's going on. Okay. Can you switch to my slides again? Thanks. Okay. So we talked about how there's state in the event handling code and all that sort of stuff. So there's good separation of concerns. Data flow as a first-class value. It's still a little bit more verbose. Oh, I'm sorry. That was actually for the second example. So we're going to run into Flux. So I took a look at Flux to see, is there anything with Flux that we could do? And I implemented this other example. Can you switch to my computer? Let's see. Sorry. So this is a budget app. It's really simple. You can click on the months and see all of the transactions. You can change the transaction and categorize it. You can see the budget. You can click on uncategorized transactions, see which ones aren't categorized. You can categorize them, and then they disappear, of course. So I use this as my Flux demo, and I learned a lot about Flux. And I was thinking hard, is there anything that we could do to improve? And let's see. I'm not going to walk through the code because I don't really have time. But you guys, most of you all probably know what Flux is. So there's basically a transaction store, a budget store, and a uncategorized transaction store, and all of those sorts of things. So can you switch back to my slides? So this is the way that I like to think about Flux, right? It squeezes everything through the dispatcher. It's really nice. because it extracts the data into one source of truth. They're not hidden in components anymore. There's an explicit forward flow. And basically the idea of, because we could theoretically want this, right? We could just have one big global data blob, and then whenever that changes, we just re-render the whole app. But in real-world code, that obviously doesn't really work as well because we want some sort of structure in our code. And I think that's why people like to split things out into stores. But splitting things out into stores is nice, too, because you have the data dependencies, so you can have one store depend on another. And it also provides the capability for components to subscribe to changes from an individual store, so just that part of the UI is re-rendered. So can we reuse an abstraction? Can we reuse any of the abstractions that we've been talking about in Flux? I thought about this a lot, and I think that it's pretty clear that the dispatcher is just a pub-sub type mechanism, right? So there's a pub-sub channel. There's actually a higher order thing called pub-sub. So I discovered that we could use, instead of using a dispatcher, we just use pub-sub. And then I use immutable.js and cursors to handle data dependency changes. So I don't really have time to go a whole lot through the code. But I will show you one piece of it. If you could switch back to my computer. So essentially, what this boils down to is that my stores are not really stores anymore. They're just processes, right? So now we have this pub-sub type mechanism where I subscribe to an event, and I do a while true, and I'm waiting for things to come in. And what's nice about this is that now I have the composability. So I could subscribe to multiple events. I could use alts to say whenever one thing happens. And I'm essentially not entirely sure. This is where I haven't used Flux enough to exactly know, come up with a great example where this is useful. But it seems like it could be useful. The other thing that could be really useful is that this channel, I could pass a transducer into here, right? So we get to reuse, or if I just want to get the name or something, then I could do something like that. So there's a lot of nice things that we might get from this. And I would actually abstract this out to not even having really stores and just having some kind of pub-sub mechanism. And to do the data dependency changes, I use the cursor abstraction. So channels don't help with the model to component notifications. That's just fine as event handlers or something, or as cursors. So that was my quick Flux research. And so I think that's about it. Could you switch back to my slides just to go through the last few real fast? So this is the architecture now. We have multiple processes instead of stores. We have cursors that we notify that do the notifications into the components. So there's potentially a lot of good stuff with this. I think it's easier to think about. I could see using this as a global app state more than I think the stores, which like to compose things in individual things. I could see taking this a step further really easily into the global app state store, which I think is a decent thing. And a lot of these concepts actually come from as well. I discovered a lot of the reasons why works the way it does, which it uses like a global app state structure. And I think David Nolan will talk about that more tomorrow. So there's some disadvantages to this too. There's still some work that needs to be done, but that's it. Thank you.